Okay, so today we're going to talk about simplifying radicals. So we dealt with radicals a lot in our last unit when we were using the quadratic formula, but if you came up with a square root, I just had you guys do 2 decimal places. Today we're going to be dealing with square roots in a slightly different manner. That's called simplifying them. That I think is actually easier than what we've been doing. You guys can have a different opinion, of course, because you get to have your own opinions because you're individual people. But we'll see what you guys think after we start going through this. So the notes for today should be titled Simplifying Radicals. Simplifying radicals. And a radical is just like a general term for any type of root. It could be a square root, it could be something called a cube root, which I don't think you've seen before. It could be a 4th root or a 5th root, 175th root. We'll talk about the different kinds of roots you can have, because square root isn't the only kind of root. Alright, so let's say that we have something like the square root of 16. Something that's nice and easy, right? Mr. Kin, what's the square root of 16?
Oh.
Don't say 8. There we go, 4. Cool. So the square root of 16 is 4. Now, for everything that we've been doing so far, I've been perfectly fine with you guys just doing the positive root. In fact, if you type in 16 on your calculator and tell your calculator to give you the square root, your calculator will only ever give you the positive root. What do you... Okay, good. Get paper. There you go. However, with something that's a square root, 4 isn't the only root. There's actually 2 roots to this. The 2 answers to this would be 4 or negative 4. And that's where that plus or minus came in on the quadratic formula. Some of you were wondering where that plus or minus came from. And it came from the fact that when you do a square root, you could have 2 answers. And the reason there's 2 answers is this is asking what number times itself is equal to 16. Okay, well 4 times 4 is 16. But negative 4 times negative 4 is also equal to positive 16. So these 2 are both answers to that question. Alright, so, but we're going to take a look at stuff that's a little more complicated than that today. So let's say we have something like the square root of 32. So if you use the calculator to do this, you're going to get a decimal answer. And I don't know if you guys noticed this about the decimals when you do them. So like if I do 32 square root, this decimal doesn't repeat anywhere. Did you guys notice that when you were doing all those square roots in the quadratic formula problems? No? Okay, cool. So this decimal won't repeat anywhere. Like it's 5, 6, 5, 8, 5, 4, 2, 4, 9. And this actually goes on for forever. My calculator can only display however many characters it can, 10 or 11. But this goes on for forever past the screen. It goes on without ever stopping. So I told you guys when we were doing the quadratic formula to write this down as 2 decimal places. So this would be 5.66, right? Because you look at the third number, and if the third number is greater than 5, then you round the second number up. Yes, no, maybe so? You guys remember? I was right here. You were there. I watched me tell you to do it. Yeah? Okay, cool. Anyway. So this is actually a number that's like pi. It's a decimal that goes on for forever with never stopping and never repeating. So it's actually like pi. And so this here, this 5.66, is just an approximation. It's not exact. Which for most things in the real world is just fine. An approximation of a square root. However, it's not exact, which is where simplifying square roots or simplifying radicals comes in. So how we're going to take the square root of 32, or radical 32, and how we're going to simplify it. This is how I teach my students to do it. There are other teachers who teach in a slightly different way, but I think this is the easiest way to do it. So we're going to take square root of 32, and off to the side I'm going to take 32, and I'm going to break this down into like the numbers that go into 32. I lost my words just for a second there. So what 2 numbers can multiply together to make 32? Anybody? 8 and 4, right? So I can do 8 and 4. I could have done 16 and 2. Don't do 32 and 1 though, because like that's not going to get you any further down to having this completely broken down, because you'll still have 32, right? So don't use 1 when you're doing a prime factorization. Okay, so neither of these two numbers are prime, right? So Caden, what can 8 break into?
4 and 2.
Yeah, so 4 and 2. Now 2 is prime, so I'm going to underline it. Prime means that the only numbers that go into it are 1 in itself. However, 4 is not, so I'm going to break 4 down further. What can I break 4 down into, Brooke? 2 and 2. I'm going to underline both of those 2's. And then this 4 over here can break down further too. And that can also break down into 2 and 2. So I've got all of these 2's, a whole mess of 2's. So here's what a square root does. Here's the purpose of a square root. It takes a number and it looks for what its prime factors are. And for every pair of prime factors, 1 prime factor gets to come outside of the square root. So for example here, do I have a pair of 2's down here?
Yeah.
Cool. So I'm going to cross them out, and I'm going to remove that pair of 2's from the prime factorization of 32. I'm going to put 1, 2 to represent the pair of 2's on the outside of the square root. Do I have another pair of 2's in here anywhere? Okay, so I'm going to cross out another pair of 2's. I'm going to put another 2 on the outside of the square root. And when I add something else out here, I'm going to multiply it by what was already there. So times the 2 that was already out there. Now, is there a third pair of 2's for this lonely little 2 right here? No. So if there's no extra pair, then whatever's left behind stays inside the square root. So the simplified version of the square root of 32 is really 2 times 2 square root 2, or if I clean this up even further, this can turn into 4 root 2. So this is the simplified version of the square root of 32. Now if you're using the quadratic formula and you got 5.66, for most situations that's okay. But now I'm teaching you guys about simplifying roots, and so if the instructions of the problem say simplify, you need to be paying attention to what the instructions say. If the instructions say simplify, then you need to be taking root 32 down to 4 root 2. Okay? So let's try another one of these together, and then I'll have you guys try one on your own. So let's do the square root of 54. So I'm going to take 54 off to the side here, and I'm going to break it down into its prime factors. So 54 can break down a bunch of different ways. I could do 9 and 6. I can do 27 and 2. So it doesn't really matter which of those 2 methods you choose to start. I'm going to do 9 and 6 just for funsies. But if you wanted to do 27 and 2, that would be fine. Stop it. Both of you. You should be taking notes right now. This is complicated. There's no reason for you to be messing around. Stop. Yes?
Okay, so I just broke it down.
Mm-hmm.
And for 9 it's 3 and 3, and for 6 it's 2 and 3.
Yep.
So you put a 3 on the outside.
Yep, so for this pair of 3's, so I'm going to cross out the pair of 3's and put 1 3 on the outside to represent it. And then there's no pair of 2's and there's no pair of 3's.
Which just put a 2 times 3 in
Mm-hmm.
the square root. Right.
So these stay inside, this 2 and 3, and if they're inside, they're going to be multiplied. 2 times 3. And then I'm just going to clean that up a little bit and make it 6 on the inside. So square root 54 turns into 3 square root 6.
It's not very complicated.
Okay? So let's try one of these like this, and then I'm going to make it a little more complicated. So the one I want you guys to try on your own, and I'll come around to help. Raise your hand if you need any help. Let's do square root 75. This one won't be too bad. So if you don't know what you're doing, raise your hand. I'll come help. And if you think you got the answer, raise your hand and I'll come check. So you're going to do the Malik. Come on. You're going to do the prime factorization to 75. Lucas, come on. You're going to do the prime factorization to 75 first. Then you're going to look for pairs. For every pair of prime factors, 1 can come outside the square root.
Isn't 5 a prime number?
5 is prime. So prime numbers are 2, 3, 5, 7, 11, 13, 17, 19. 23. That's fine. So there's a pair. So you cross those two out, even though they're not right next to each other. Put 1 5 on the outside, and then what's left on the inside? Just the 3. So you're not counting that 15 there.
I had to think what she did.
Yep. So it doesn't matter if the 5s are right next to each other, so long as there's a pair of them. Okay. Yep, except you don't want to count for 1. So like just count for 3, 5, and 5. So is there a pair of 5s? Okay, so put 1 5 on the outside, cross out the 5. Alright. And now inside is where
It takes better than it normally does, so.
the other one's depends on those. Okay. So when you're doing your prime factorizations, you don't want to use 1, but if you do, it's not the end of the world. Oh, no. Yeah, 5 is 2. So 75 isn't 5 times 5. So there's a bunch of different ways you could write this down. Just because you do it one way doesn't mean everybody else has to do it the exact same way. So 75 could be 25 and 3. It could be 15 and 5. Those are the only two things it could be. Yeah. So if you did 25 and 3, that's fine. If you did 15 and 5, that's fine. You'll get the same answer as anybody else, so long as you're being cautious about what you're doing. Perfect. Okay. So that's what a square root does. It looks for pairs of prime factors, and for every pair of a prime factor, 1 can come outside the square root. Kind of, sort of. All right. So let's take a look at this is algebra, and I always make things a little more complicated once you guys seem to be understanding anything. So I'm going to throw this just a tiny bit of a curveball at you and make this a little more complicated. So let's say we have the square root of 120, x to the third, y to the fourth, z to the fifth. Okay. This really isn't that bad. Just bear with me here. Okay? Just give me a second. So we're going to break this into 2 pieces. So one piece is the number piece, and then the other piece is the variable piece. So for the number piece here, I've got 120. And there's a bunch of different ways you can break down 120. Colton, what can go into 120? Come on, man, it ends in a 0. What goes into every number that ends in 0? 20 does, sure. 20 and 6 is one way I could break it down. You could break it down as 12 and 10. You could break it down as 40 and 3. You could break it down as 30 and 4. There's so many different ways you could break this down.
I like how you told him what number could always go into.
I know, and
he's like 20.
Yeah, 20 doesn't always go into things that end in 0, but I'll take what I get. So Colton, what can 6 break into?
3.
Okay, those are both prime, so I'm going to underline them. Colton, what can 20 break into? 5 and 4. 5 is prime, but 4 isn't. So Colton, what can 4 break into? 2 and 2. And those are both prime. Okay, cool. So now I'm going to go through and look to see if I have any pairs of things. So is there a pair of 5s? Anybody?
There's a pair of 2s, that's it.
Yeah, there's a pair of 2s, no 3s, and there's not another pair of 2s. So I'm going to cross out 2 of the 2s. Doesn't matter which 2 either. You could cross out this 2 and that 2. They don't have to be the 2 that are right next to each other. So I'm going to cross out 2 of the 2s and put 1 2 on the outside. Now on the inside now of the square root, I'm going to have 5 times 3 times 2. So 5 times 3 times 2. All right, now let's deal with the variable part here. Now to do the variables, and again, this is just the way that I think is easiest to explain how to do this, I'm going to take these variables each and expand them. And what I mean by that is instead of having it be x to the third, I'm going to write x times x times x. Instead of y to the fourth, I'm going to write y times y times y times y. And instead of z to the fifth, I'm going to write z times z times z times z times z. So I've got 3 x's here, 4 y's, and 5 z's. All right. Now the rules are the same for variables that they are with the plain numbers. I check to see if there's a pair, and if there's a pair, 1 can come out. So here, there's a pair of x's, so I'm going to cross out 2 of the x's, and 1 x can come outside the square root. Now there isn't a second pair of x's.
So one x goes in the square root.
Right, so this other x stays inside the square root.
So would there just not be any y's in the square root then in that case?
Right, so here I'm going to cross out 2 of the y's to put 1 y on the outside.
We just put it to the square root?
Yeah, you can, yeah. So I'm going to cross out another set of y's to put another y on the outside, and then there's no y's left, so there's no y inside the square root. Z's, I've got a pair of z's, so I'm going to cross out 2 of those and put 1 on the outside. Got another pair, I'm going to put another z on the outside, and then I've got 1 z left on the inside. Now I'm going to clean this up a little bit here.
So would it be 2x, y to the second, z to the second,
Mm-hmm.
and inside the square root is 30x z?
Yep. So let me just go through that. So on the outside I've got 2, and there's no number to multiply it by, so the 2 stays there. X has no x to multiply by, so it stays x. But what's y times y? Do you guys remember that? From like a month ago? Y to the second, and z times z is z to the second, okay? Inside the square root, I've got 5 times 3, which is 15, times 2, which is 30, and then x and z are both also inside the square root. And then this would be the answer to that. Kind of, sort of? Okay. All right. So let's go through this together then. At least the first part. This is going to be due, this assignment I'm about to give out is going to be due on Thursday, but that doesn't mean we're going to have a ton of time to do it tomorrow in class. Tomorrow we're going to be dealing with this, but then also some other stuff. So we will have some time to work on this tomorrow in class, but not a ton. So don't count on having the entire
Do you
class.
have our plans real quick?
So hold on, let's go over part of this together as a class, and then yes, we can. All right, so let's go over, I don't know, 2 or 3 of these at least as a class. Make sure everybody's on the same page. Okay. So, let's take a look at question number 1 here. So we're going to break it into number part and variable part. So, number part is going to be 112, and variable part is everything else.